Assalamu alaikum. Unit 1 Electricity, Chapter 5 Generators and Receivers. In our previous video, we have studied receivers, its characteristics, its IU curve and Ohm's law of a receiver. In our last video, we will have some direct applications on generators and receivers in electric circuits. Let's start with our first application. Consider the adjacent circuit which contains two generators, G1 of electromotive force E1 equal 25 volt and internal resistance R1 equal 1 ohm, G2 of electromotive force 15 volt and internal resistance 1.5 ohm, a motor which is a receiver of back electromotive force 6 volt and internal resistance 1 ohm, and a resistor of resistance 4.5 ohm. Specify the role of a G1 and a G2, then deduce the direction of the electric current. Think about the question carefully. Yes, since G1 and G2 are grouped in opposition, we need to compare the electromotive forces of both generators. Since E1, which is equal to 25 volt, is greater than E2, which is equal to 15 volt, then G1 acts as a generator and G2 acts as a receiver. Then G1 imposes the direction of the electric current in the circuit, and the current moves or flows from the positive pole of a G1 in this direction. Now apply the law of addition of voltage to show that the intensity of the current I is equal to E1 minus E2 minus E divided by R1 plus R2 plus R prime plus R, then deduce the value of I. Starting from the law of addition of voltage in series grouping, we can say that the voltage across the generator is equal to the voltage across the motor plus the voltage across the resistor plus the voltage across the second generator, which acts as a receiver. Now you need to apply Ohm's law on each of these. Applying Ohm's law on the generator gives us UG1 is equal to E1 minus R1I. Applying Ohm's law on the rest of the portions of the circuit gives us that the voltage across the motor is equal to E plus R prime I, which is Ohm's law of a receiver. UR is equal to RI. UG2 is equal to E2 plus R2I, since G2 in this case acts as a receiver. Then you apply Ohm's law of a receiver. Now substitute in the previous formula gives us E1 minus R1I is equal to E plus R prime I plus RI plus E2 plus R2I. Now gather the current at one side. This gives you that E1 minus E2 minus E is equal to I into R prime plus R plus R2 plus R1. Now I is equal to E1 minus E2 minus E divided by R1 plus R2 plus R prime plus R, since we have divided these by those. Substituting each one of these by its value gives us 0.5 ampere. Try the solution yourself. Now determine the voltage UAB across the terminals of the motor. The motor is a receiver whose voltage UAB is equal to E plus R prime I. Applying Ohm's law for a receiver, we have the value of the back electromotive force and the internal resistance of the motor, and we have calculated the intensity of the current in the circuit. Substituting each by its value gives us that the voltage across the motor is equal to 6.5 volt. Now the motor M is now replaced by another motor M prime of back electromotive force 12 volt and internal resistance 1 ohm. Show that M prime is not spinning or rotating, in other words, is not functioning in the electric circuit. For the engine of the motor to run, the total electromotive force in the circuit should be greater than the back electromotive force of the motor. The total electromotive force in the circuit is equal to the difference in the two electromotive forces of the two generators since they are connected in opposition. Then E total is equal to E1 minus E2. It is equal to 25 minus 15 is equal to 10 volt, which is smaller than the back electromotive force of the new motor. Then the motor and prime will not operate. Now you need to suggest or propose a method for M prime to operate. Simply, you can reverse the connection of the two batteries so that they become grouped in series, where the total electromotive force is equal to the addition of the electromotive forces of the two batteries, which gives us 40 volt, which is greater than the back electromotive force of the motor. In our second application, consider the adjacent circuit. The circuit contains a generator of unknown electromotive force and internal resistance. We have a resistor connected in series with a generator of unknown resistance R. We have a resistor R1 of resistance 9 ohm connected in parallel with a motor of back electromotive force 4 volt and of internal resistance 5 ohm. The current traversing R1 is equal to 0.5 ampere as indicated in the figure. First, you need to calculate the voltage UAB. Applying Ohm's law, UAB is equal to R1I. Applying Ohm's law on the resistor R1, UAB is equal to R1I1. Replace each one by its value or substitute each one by its value gives you 4.5 volt. Now you need to calculate the current I2 that traverses the motor M. Applying the law of uniqueness of voltage in parallel grouping, UAB across the terminal of the resistor R1 is equal to UAB across the terminal of the motor. Then UAB is equal to 4.5 volt, which is equal in this case to E plus R prime I2, applying Ohm's law on the motor. Then I2 is equal to UM minus E divided by R prime. Substituting each by its value gives you that the current I2 traversing the motor is equal to 0.1 ampere. Now the adjacent graph showed the variation of the voltage across the generator as a function of the intensity of the current it generates. First, you need to determine the equation of this curve. Since the curve is a decreasing straight line not passing through the origin, then the equation is UG is equal to AI plus B. We need to determine A and B. A is the slope of the curve. It is equal to delta UG divided by delta I. We have here the coordinates of 2 points. Substituting them in the equation gives us that the slope is equal to minus 4 volt per ampere. B at the y-intercept, we can calculate its value by substituting any one of these 2 points in the equation. This gives us that B is equal to 8 and the equation becomes U equal minus 4I plus 8. Now we need to deduce E and R, the characteristics of the generator G. The voltage across the generator is equal to E minus Ri, applying Ohm's law of a generator. By comparing this formula to the formula obtained in the previous part, we can notice that the electromotive force of the generator is equal to 8 volt and the internal resistance of the generator is equal to 4 ohms. Now we need to calculate the voltage UPN across the generator. UPN is equal to minus Ri plus E. Applying Ohm's law of a generator, we have the internal resistance of the generator and its electromotive force. We still need to calculate I. I is equal to I1 plus I2, applying the law of addition of voltage in parallel grouping. Substitute each one by its value gives us that the voltage UPN is equal to 5.6 volt. Now we need to determine the value of the resistance R. Before calculating R, we need to calculate the voltage UPA. We apply the law of addition of voltage in series grouping, where UPN is equal to UPA plus UAB plus UBN. UBN is equal to 0 volt since it is a connecting wire. Then UPA is equal to UPN minus UAB and it is equal to 1.1 volt. Now, applying Ohm's law, R equal UPA divided by I, which gives us 1.83 ohms. Now, dear students, please refer to your agenda to solve the indicated exercises. Also, please visit the link to test yourself. Your result will be checked by your teacher. And thanks for watching.